So before we dive into the Q&A, and we've heard from three great speakers, the last speaker here, I'm going to welcome back Michael Berthold. Hi, Michael.
Hi, Sasha.
So last time you talked about what is and what isn't AI, and I hear this time you're going to continue that conversation.
That was the idea of the talk, even though it's a bit of a break from the previous topics. And I think that it's not a coincidence that the previous conversations I don't think I heard the AI buzzword once, right? And that means they're doing real stuff that produces real value, and I'll try to explain a little bit more today why using AI requires quite a bit of babysitting.
Great.
Thank you, Sasha. I wasn't allowed to use this title by marketing. That's why in the agenda it says something else, but I really think that's what this is all about. But before I start talking, talking about what I really want to talk about, maybe it's worth briefly remembering what I presented, what we discussed at the Fall Summit in 21 last year, where I was trying, as Sasha just pointed out, I was trying to explain a little bit more what is actually AI, because these days everybody is an AI company, everybody is doing AI, everybody is doing something AI-ish, and I don't think really that's true. So what I was trying to contrast a bit, talk about expert systems versus intelligent systems, right? On the one side, we have systems that got engineered, where every part of a program or the machine or whatever was actually designed and created by a human, right? The responsibility for the correctness, and that could be fairness or that it's doing ethically proper things, lies with the creator of that, usually a program, right? I can go back, identify the line of code or the piece of the machinery, who designed it in principle at least, if documentation was done properly, and then talk to that person. Why did you write this line this way, right? Was that intentional? Maybe not, but then we need to fix it, right? So also in principle, this kind of product is verifiable against the specification. So I can sit down and say, I want the system to do this, this, and this. Does my program really do this, right? In contrast to that, we have intelligent systems where the learning system was created by a human being, right? Humans have written the algorithm that actually generates the system, learns from data usually. Here, the correctness, the fairness, the ethicalness of the resulting box that makes decisions, for instance, relies on people picking the right learning method and picking the proper data, and I'll get back to that in a second. So in this particular case, it's a lot harder to verify correct function, right? And it's important to not simply say, engineering systems, that's the simple stuff, and the intelligence system, that's the complex stuff, because that's also something I said last year in fall. Not everything we don't understand is automatically AI, right? It may just be something that's extremely smartly engineered. I'm pretty sure the previous three speakers will not claim that what they build is an artificially intelligent system, even though from the outside it's doing pretty smart stuff, pretty intelligent stuff, maybe even for the non-engineer. But underneath the hood, a couple of engineers have done amazing work. I also then briefly talk about, so whose fault is it then when AI fails? So when AI does something weird, makes a discriminatory decision, or makes a decision where I just think, really? I mean, I'm currently driving an e-car. I'm not trying to mention who the vendor was, but that e-car sometimes makes decision when I go on autopilot where I think, really? What have you been smoking? Right? So whose fault is it? Could be the creator of the learning method, right? Then you need to go back to the academic group and say, well, you guys, the algorithm that you did resulted in my car doing strange things. That cannot quite be the case, right? It could be the person that picked the method. That's probably a little bit closer to the truth. Or it could be the provider of the data, and that's most often the problem, right? The data is wrong, biased, incomplete, doesn't have examples for the weird things that are just currently happening, right? In reality, the biggest problem for real AI systems, it's not that easy to realize when data or method are wrong. So you pick best conscious effort, right? You're trying to do the best thing you can. And then afterwards you say, oh, right, I should have thought about that one. So what can we do? If AI can't be trusted, we can, of course, lock it up. But maybe there are other things that we can do. And I wanted to mention 5 of the currently kind of hot topics and then talk about a few very pragmatic ways to actually fix some of the issues around AI, not being able to trust AI. Before we do that, just so that I can use diagrams to illustrate some of these things, AI in a very, very coarse nutshell is about learning a model, learning an artificial intelligence model and applying it, right? So we have a chain up there, training data. We feed that into some sort of a training, learning algorithm, and out comes a model. And I'm aware often that model, and especially us at NIME, we are of course always talking, we are actually emphasizing the fact that models include a lot of data massaging, data pre-processing as well. So that's important to keep in mind. For today, we'll just talk about a model, the AI model, and then I'll use new data that comes to me, sensors when I drive around from the street, they get fed into the model and they result in decisions and predictions, in steering signals, whatever. The first thing I can do, and it's one of these buzzwords out there, XAI, explainable AI, sounds great. So you can explain what the AI is doing. Not quite. What you actually can do is you can look at the output during this prediction phase when you're actually applying the model and say, okay, and then you can analyze and get a little bit more information on, okay, so which of the parameters that went into the model were actually used or influenced that decision more heavily than maybe some others, right? Was age of the candidate an influencing factor in the decision or not, right? These types of questions. Maybe you can even ask things like, how did it influence it? So if age goes up, what happens to the decision? These types of questions. And sometimes you can go a little bit deeper and even approximate the decision process itself and get a bit more of a feeling for, okay, this is what, in this vicinity of the current data point, what the model looks like. So the problem here is explainable AI doesn't really explain the model. It explains, and even that only partially, very often, just a particular decision or a group of decisions. You're not going to get really an insight into what the AI was thinking, so to speak. So we can go a step further and say, let's do that then. Let's explain AI. Explaining AI would mean that you have something that takes the model and turns it into, well, a human readable representation. So something that I as a human, or maybe even a team of humans, looks at and says, now we know what's really going on. And that's simply infeasible, because if we were able to do that, wouldn't that mean we could have written that? And even if we'd argue that maybe, no, you couldn't write that because it was derived from the data, I'd probably still use this type of a system only as kind of a recommendation or as an AI-assisted expert system, right? I use the training data, create the model, then I create that human readable representation to validate and say, yes, this all makes sense, let's move this into production. Or more likely, you're going to say, something's missing, let's add a rule or something here as well. So that works essentially for simplistic models that are easy to translate into something that's human readable, which kind of defeats the purpose of AI, right? The AI idea is build fairly complicated systems that you can't build with a couple of human readable rules. The other buzzword that's currently floating around is data-centric AI. I hinted at that before. This goes back to the training part of the process, right? The upper part of the diagram I showed at the beginning, where we're essentially saying, well, it's very easy, right? Just make sure that what we feed into the learning method has proper coverage of all of the groups that we're interested in making predictions on in the future, excludes all unethical features, and it actually goes further. Just excluding unethical features is not enough. You also need to make sure that none of the other features accidentally allow the model to learn some of these unethical features. So it turns actually into a pretty complicated problem. So data-centric AI, fantastic idea. Just give me the right data to learn from. And we have all read these news reports about racist news article writing AI systems and other types of things where it just went disastrously wrong. It's not as easy as it sounds, right? Data-centric AI requires proper data, which requires lots of domain expertise. And it's, again, one of these cases where very often you're going to train your AI on some data, and then you're going to realize after it's in production, it's like, that's making really strange mistakes in certain circumstances. We say, yes, right, we didn't have examples for that one as part of our data. Let's add that. So this data-centric AI is more something where step by step you start improving the data coverage. It's not something you can design from scratch from the beginning. And then the newest trend, or it's actually, I'll get to that in a second, it's also a very old trend again, is what we call hybrid AI, right? And that kind of affects both of these pieces because it's really about injecting domain knowledge, right? Injecting domain knowledge either into the training process or into the model prediction process. It kind of goes two directions. You can add human expertise to the AI system, or you can add AI collaborators to human reasoning, right? So you can use the AI system during the prediction process, when you actually put it in production, to recommend certain actions and then use domain knowledge elsewhere to refine that. Or you already initialize your system. You start, before you even start training from data, you're already adding knowledge representations to that one. A little side note here. a lot of this adding human expertise to AI systems, that's pretty hardcore machine learning in a sense. There's active learning. It's an entire field of research. NIME has notes that allow you to do these types of things and add that expert feedback into the learning of the model itself. And then we have on the other side for adding AI collaborators to human reasoning, that's really data apps, right? That's really all about deploying interactive analytics, interactive AI models to users that can then use those to, well, start forming and revising hypotheses. Also here, of course, hybrid AI requires a separate knowledge representation, which requires appropriate additional resources, lots of work. To me, honestly, it sounds a little bit, a really complete semantic knowledge representation sounds suspiciously like the old data warehouse, which is a fantastic idea, but I have yet to see a complete, wonderful data warehouse architecture that survives more than 3 days in reality. And I think the same is going to be true with these complete knowledge representations. A little flashback, because I kind of have déjà vus often these past years. I mean, if you actually look at that, and I mentioned that before, hybrid AI is actually not all that new, right? If you look at how AI started, this is very coarse. None of these years are precise to the year, but just to give you a bit of an idea. In the 60s, AI started, right? And it was mostly symbolic AI. We were talking about rule-based, very high-level semantic kind of representations. Interpretable AI, that's what was often learned from data. It was rule systems, inductive logic programming came from there. They actually generated something from data that a human could read. Then there was this boom of neural networks, right, called connectionist AI, or sub-symbolic AI, where we were betting a lot more on distributed representation, the very low-level representation, extremely data-driven learning. None of the parameters in the system usually made any sense, but together they performed pretty amazing tasks. That ran a little bit into a wall because people realized, a little bit like today, that yes, this is great. We can do amazing things that humans can't do. There's no doubt about it. I'm not doubting that AI can do things that are extremely useful. But they also found out it's extremely hard to control that AI doesn't do really stupid things at the same time as well. So they started talking about combining symbolic and neural learning at that time already. And it was a very similar argument to hybrid AI these days. Make sure, well, I mean, we can learn from data, combine the power of learning from data with the knowledge representation of what humans should know anyway, right? So you avoid those totally silly mistakes. And then, of course, in the 2010, somewhere around there, deep learning popped up, which to me is really connectionist on steroids in a sense, because it's about having tons more compute power, being able to add many, many more parameters, deep networks, gigantic networks, and with that much more compute power and deeper network structures, we also get more predictive power. So now we can do, again, amazing things, even more amazing things than in the 80s. Some of those you have seen in the news yourself as well. But we run into exactly the same problem again. So hybrid AI, back to trying to combine symbolic and neural learning. Same idea again. But I think what's happening is my prediction, and I should never do predictions. I've been in data science way too long that I know all predictions about the future tend to be wrong. But anyway, I think we'll hit again more of a plateau where AI usage, we can now do cooler things with deep learning, but it's going to be checked and balanced a little bit more, and it reaches something where I say, okay, these types of applications, makes lots of sense to use it there. Some other applications, let's stay away from those. Okay, so if we cannot completely trust AI, what else can we do? I mean, all of the things I said, you need a complete world knowledge, semantic representation, doesn't really work, but is there something very pragmatic where we can start doing that today? And we can. I call it protecting AI. It's really the same thing. It goes back to data-centric AI. Just make sure you don't pass data to the AI that's outside what it was trained on, right? So let's flip this around. Instead of making sure the data that I'm providing is perfect and wonderful and represents anything that could ever happen, I'm going to say, you know, we're pretty sure we trained the AI well on these scenarios. Before we hand data to the AI, let's filter out anything else. Right, so there's going to be a filter in front of the model that says anything that we didn't use for train, that we didn't represent during the training process. That's something we trust the AI to deal with. The decision predictions, everything else, we ask someone else, right? Have you ever seen something like this? This may, again, result in you adding more data to your training data and then relaxing some of these data filters, but it's the opposite approach. Examples, right? I mean, if I trained my engine failure neural network on trucks, maybe we shouldn't apply that to small SUVs, right? If I actually even, so some of these SUVs have 8 cylinders. But anyway, don't predict a credit score in a teenager, right? If it, or younger than 18, if that wasn't part of my training pool anyway. And maybe let's not use a system that was trained on US speakers, on UK speakers to predict US speakers' speech, right? Transcribe US speakers' speech. So we require domain-specific filter rules, but it goes from the opposite direction, right? We're not going to filter out everything. We're not going to make sure the data is complete, but we are going to be very aware that the data is incomplete, and we're just going to make sure that the AI is only applied where it's safe. We can also go the opposite direction, say, let's protect the world from bad AI decisions, right? Which essentially means we're going to check the decisions for weird outcomes. So we're going to have some decision filters here that essentially say, okay, this is fine, that can just go pass by like this one, but for this one, we really want to do a sanity check, right? Which essentially means you're going to say something, if I'm automatically controlling the speed of my engine, there's going to be some sort of a filter where I'm going to say, I'm only going to allow you in sort of a safe range to adjust anything. Anything outside that one, if you really want to slow down my car engine to less than 100 RPM, we're going to check with an expert first, right? Or you could also say, well, let's run my credit scoring system on everybody that applies, but let's just make sure we double check the teenagers, right? We don't want to miss the next Bill Gates, but probably everybody else where the system said, yes, let's give them a credit over 10 million is a horrible idea, right? And same story, you could also use this to essentially observe what's going on with your predictions and say, why do we keep making such bad transcriptions for our US speakers and then handing that to somebody else who actually listens to the recordings? So again, we require domain-specific inspection triggers, where we're essentially saying we trust the AI to make these types of adjustments, decisions, but any other decision, we want a sanity check. And then, of course, there's the other one with Handholding AI, where you're running an expert model in parallel, because to be honest, a lot of these applications aren't coming completely from scratch, but there are other systems in place already, so why not run those in parallel, have a supervisor that essentially says, you know, if they're totally out of whack with what our previous system would have said, maybe let's not just discard them, but let's inspect and see what's going on, right? Examples here, right, your expert system says, let's go 20 miles per hour, like my car recently tried to slow down to 30 kilometers per hour in the middle of the highway, and I thought, what the hell is going on? And the AI claims 200 kilometers or vice versa. Something where maybe want to double check if one of the two is not quite right. Or your AI claims, hey, this person is good for $1 million credit, and your expert model says, let's maybe give them $100, but not more. Again, something where you want to look into it. Again, we require classic expert design systems, and in many cases we actually have those. Let's run them in parallel. They weren't so bad in the first place. And then, of course, the reality is it's a combination of all of this stuff. Let's focus on providing proper training data. Let's focus on injecting domain knowledge where we can, filter the data that we pass into the AI, run an expert model in parallel, have the supervisor checking these two decisions, also checking the outputs of the AI if they're reasonably meaningful, and that should get us a lot closer to trustworthy and ethical decisions. So to me, practical, to summarize what I was trying to say, practical steps towards hybrid AI really are if you can't tolerate really weird mistakes, right? I think that's the first point. If weird mistakes aren't an issue and you're just going to laugh and say, okay, let's fix the system, and then starting tomorrow it's not so bad. So it's catastrophic, weird mistakes don't really have catastrophic outcome. Then run it and play with it. But if you can't tolerate that, make sure you babysit your AI properly. Which means you really have 3 options in production: only pass validated data to the AI, double check the decisions of the AI, just make sure you have essentially filters for, those sound like sane decisions by my AI, or run a parallel, often dumber, but human-built model that double checks some of the things that are going on. And well, that's the Handholding the AI. And by the way, all of these pictures were done by Cassiana here on the team. She's fantastic with those robots. Neither of this, and this is something I can just hammer enough, neither of these helps, of course, if you forgot to pick data and learning method carefully. Designing your AI properly makes a lot of sense, and you didn't establish reliable, repeatable productionizations of your models. All of these topics around XOps, but that would be a topic for a completely separate conversation. So I'll leave you, and I think the 3 talks before me are actually really make this point even stronger than I can make it now. If before you apply or throw AI into the mix, make sure you use plenty of natural intelligence to find out, is it really necessary? I read an interesting article a couple of weeks ago where they were also arguing, I mean, before throwing AI at stuff, sometimes a regression line is enough. A regression line is a lot more robust. It's a lot easier to interpret what's going on. Often smart engineering can really help avoid AI altogether. It's another one of those cases where I have a lot of déjà vus. When I remember the times when I was at Carnegie Mellon doing neural networks, we were doing neural networks research, and every problem, everybody was always solving every problem with gradient descent. We just think there's a closed solution for that, but don't use gradient descent, right? It's the same. There's this hype about AI you see applied. You see AI, deep learning applied all over the place, where sometimes you think, really, think a little bit, and that's probably a problem that you can solve a lot better, a lot cleaner, a lot more robust, a lot more transparent with classic technologies. That's what I wanted to cover today. I'm not going to be part of the QA session that's starting in 30 seconds, but I'm going to go through the QA section of the tool, the event platform later, and I'll answer to some of those. And do reach out to me on LinkedIn or via email if you have comments on this one. I'm very curious to hear your take.